exponential and logarithmic equations. Okay, so there's equal signs. And yesterday we were just starting pretty basic where we had exponentials on both sides of our equal sign. And we wanted to make sure that before we set those exponents equal to each other that we found a common base. All right, not always going to be that easy. What I want to remind you of first before we get into the next part is if an equation or an inequality involves a single exponential function, we can solve it by converting between exponential and logs. That's what we did in section 4. So just to remind yourself of this, here's your exponential and here's your log, okay? So I'm going to give you just one quick example, and I just want you to solve the equation by converting it from an exponential to a log. Okay, so here it is. What do I want? 4 to the x equals 11. Now this is something you're going to use your calculator for, because 4 to the something power is never going to equal exactly 11 if x is a whole number, right? It's going to be a fraction. It's going to be kind of a crazy looking number. So what I want you to do first is convert it to a log. So what would it be? Log base what? Yeah? 4. Of 11 equals, okay. So that's actually an answer. My directions said give the exact value and then give it rounded to the nearest, 3 decimals. So that is one of your answers. That is the answer in exact form. Okay? Do you remember how to put that in your calculator? Yeah, you can do one of two things. You can press the log button on your calculator and go back and delete your base, or you can do the toolbox. So when you do that, that's what's going to give you a rounded number. Is it kind of crazy looking?
Maybe.
1 point.
I think I typed it in.
Yeah, because Luna, you can't do this, you can't do this. Yeah, your 11 isn't. Okay, you now type in 11.
1.729.
Yeah, so what's after a 9?
7, so 1.730.
Okay. Yeah. So did you press this?
Yeah.
Okay, so log, delete the 10 and put a 4, and then of 11. For some reason your parentheses went away. I don't know the buttons that you had pressed, but it did work. Yeah.
Can I take the list?
Sure.
And you said this was, what form was this?
This is the decimal form, the rounded number.
The rounded number.
So either one would be correct.
I asked for both, so both are correct. Isabella.
Never mind. I thought it was just one and I got it.
Sorry, I just didn't finish writing it.
No.
Yes. Okay. So, what we're getting into next is when there is exponentials only on one side of your equation, okay? So, there's going to have to be some converting that we're going to have to do. What we do want when we're doing these examples is to check for extraneous solutions, because using properties of logs can sometimes lead to solutions that take the log of a non-positive number. So I want you to type this in your calculator. Press the log button. It gives you log base 10 of -5.
Every time I write, it's like writing
Non-real?
Yeah. Non-real. So your answer is undefined. And there would be no answer, right? So you can write no solution when that happens. But some of these, like you may get -5 as an answer. You got to plug it back in. -5 sounds like a great answer, but when you plug it back in, you get something like that. Yeah?
Is it because it's a negative?
Yes.
Or is it just, okay.
Yes, it's because it's a
So
negative.
if you ever see like log 4 4 to like the negative something power, or like log anything to the
I think so.
power,
Yes.
it'll
Yes.
always be like undefined or not real.
Yes. Well, like, I'm not going to say always, like, the answer is yes to that. It says sometimes they can lead to no solution. So I would just check it in your calculator. You can do the checking in your calculator. It does it for you. Yeah.
Could you charge my calculator?
Yeah, bring it up here. How about the log of 0?
Undefined.
Thank you so much.
Wait,
It is undefined.
what's the difference between non-real and undefined?
That's the same thing. If you get non-real, it's undefined. Non-real means it could be imaginary, but there's just not an answer that we're considering. Okay? Now, why does this make sense to you? It doesn't. Well, let's fix that.
Because
If you were, what's the base of that?
10,
10 to the what power equals 0?
nothing.
That's why it's undefined. Like, you can't raise anything to a power n equals 0.
It's 0.
Does that make sense?
Yeah. But
That's why it's undefined.
Yeah. But if you like raise something to a 1, you get a 0.
Yeah, exactly. Yeah. Okay. All right, so here's the steps for solving these kind of exponentials. So when an equation has more than one exponential function, we can often solve the equations by finding common bases and using properties of exponents. That's what we were doing before. Now, when we only have one exponential, I'm going to want you to change it to a log. So, get it by itself, change it to a log, then solve for the variable. I'm going to probably ask you for the exact answer and the rounded answer, and then you're going to have to check them. Okay? You can use your calculator to check them. All right? So here is our first example. Where is it? It looks crazy. It looks crazy. But I just need you to follow those steps, and I need you to think, what am I doing? I'm solving this equation. So you're getting x by itself. Are you with me? Yeah?
I have a question.
Yeah?
So, is this where we need to make the bases the same?
Well, no.
Okay.
No. The directions say isolate the exponential on one side. So what is the exponential? The exponential is this.
Oh, the whole thing?
Just the e to the power. So that's not by itself. How do you get it by itself? Divide by 3 on both sides. That's a good place to start. So here's what we have. E to the 9x power equals 5. Now is that exponential by itself? Yes. It is e to a power. Whatever is raised to a power, that's what you need by itself. Now I need you to convert it to the log form. So be careful about this because my base is e, right? So if it's a log base e of 5 equals 9x, you could also write it like this. The natural log of 5 equals 9x. I would probably do it this way because remember that that's a button in your calculator. Can you get x by itself now? So here's what you did. You got the exponential by itself. You converted to logs. Now solve for the variable. How would I get the variable by itself? There's a 9 with it and it's being multiplied. So how do you undo that? Divide by 9. That's all you're doing. Yeah. So here's what you have. I'm going to go down here. I'm sorry that I ran out of room. That is the exact answer. Make a note for yourself. Exact answer. And I ask for that. How are you going to get the rounded answer? Put it in your calculator. That's a great idea.
Wait, so you put that in your calculator?
You would put this whole thing in your calculator. Yes. Now, did anybody try it in the equations app? What? No?
Should we? Is it gonna be like a good answer?
I don't know. Can you try it
Yeah.
in the equations app? I just have never done that. I'm requiring you to show your work. That's in the directions. Do you see how it says show your work? So if you don't have work there, you're not going to get credit for it. But it is a good way to maybe check your work, right? I just want to know if it gives you the exact answer and the rounded answer in the equations app.
0.178.
Did I?
The equation has no solution in the equations app.
Let me see how you typed it in. No, Lizzie. What did you say the rounded answer was? 0.
Oh, 0.178, so then it would be 0.179.
So if I rounded to 3 decimals, so what was the fourth number?
8, so it would be 0.179.
The other one was an 8, is what you're saying?
Yep.
Did you try it in your equations app?
Yes.
Yeah, in the equations app it has a
Okay, that's not the equation. Hold on. Type the original equation in there.
Okay. So, this,
This.
that,
The original equation. 3. Hang on. Sorry.
get in there. That peg thing. So
3 times E. You see E right here? Yeah. E is next to the natural log button. 9x go over, and then press equals 15. Okay, so that gave you, okay, so listen. You can put this original equation in your equations app. It only gives you the rounded answer. And I am going to always ask you for the exact answer and the rounded answer. So you're going to have to show me your work. You're going to have to know how to do this by hand. You can check it in your calculator, but you got to know how to solve it. Are you with me? Juliana?
So since you always ask for both, is it okay if we did it by hand and then in order to get the rounded answer, we just input it in our calculator?
Sure, but you can also just type this in your calculator. Did you try that?
No, I didn't actually.
So, do you know where the natural log button is? The natural log of 5, and then divide that by 9, and you should get it. Okay, I'm going to go down to the next page for my second example. Here we go. 5 times 10 to the negative 3x power plus 4 equals 14. There's a lot going on here, but what is our first step? Isolate the exponent. This was your rounded answer.
Would you
Yes.
subtract 4 and
Yes.
divide by 5?
Yes. You are trying to get this by itself. So I would agree. Minus 4. Divide by 5. I forgot an X. There we go. You isolated it. That was step 1. Step 2, make it a log. Convert it.
Can you just put natural log?
No, this one's a common log. Your natural log happens when you're, oh my God. I don't know what just happened. The natural log happened on the last one because my base was an E.
Yeah, but I feel like that was just when it was 10.
So that's the common log.
Okay.
And it's the word log with no base.
Okay.
Are you with me?
10
Log, yes.
Log 10 to... Wait, so you have to put log 10 or no? Because
You don't have to put the 10. You have to put the word log, but you don't have to put the 10.
I wasn't sure because of this one.
It's assumed that it's there.
Yeah.
If you write it there, it's not wrong because that's what your calculator does. Okay, what's the last step to get x by itself? Divide by a negative 3. Good job. Now remember, I've said this a couple of times. I don't like negatives in my denominator. So if you just bring the negative out to the front and write log of 2, the common log of 2 over 3 with the negative out in front, that is your exact answer. You're done. Well, you're not done, but you're done with the solving of it. Yeah?
Are you allowed to put 10 in your exact?
Sure.
Okay.
Right here, you mean?
Yeah.
Yeah, as long as it's the base. Now, you can type this. Everybody do it in your calculator, in the calculations part. Put a negative, and then do the log button. The 10 should appear of 2, close the parentheses, and then make sure your divided by 3 goes to the denominator. Like, make sure it looks exactly like that. Yeah, you got it. Negative 0.1.
Yeah.
Did everybody else get that?
Yeah.
And then there's some other zeros at the end of it. If you didn't, I will come and look at your calculator.
This is making it the log is like when you write out the log. This is the one where you can do like the little.
You
like,
can.
loop method,
Yeah,
right?
sure. Okay, here's number 3. 6 e to the x power plus 18 equals 6. My goal, first of all, is to get e to the x by itself. So, do you have a question?
Wouldn't it be undefined?
Why?
Because it's a negative.
What is a negative?
If you were subtracting 18, you'd get negative 12.
Okay.
Divide by 6, you'd still get a negative 2.
Okay, let's do that. So at this point, you're right. You would probably be like, oh, I'm questioning that. Okay. But let's maybe check it. If you convert it, oh my gosh, sorry. The natural log of negative 2 equals x. That's your exact answer. Type that into your equations or into your calculator. There you go.
So just like triple check or something.
Right, I would, because just because you think there's a negative on the other side doesn't mean it's always going to stay there, right?
Can we just put non-real or we just want no?
Just no solution's good. Yeah.
Even when it says undefined.
Undefined or no solution would be good. Yeah. Do we feel okay about that? Yeah? Okay. So that was exponentials, where there was exponentials on both sides and we got the common base, where there was exponentials on one side and you had to convert to a log and solve. Isabella?
Would ln minus 2 equals x be exact?
It would if there was an answer, but there's not an answer. Yeah.
If there isn't an answer, then we don't even really have to put the exact.
No.
solution.
No, I don't want an answer if there's no solution. Yeah, you're right. Good job. Okay, now we're going to do the easiest of the logs, and then we're going to move to where it's a little bit harder, okay? So we have that same one-to-one property that we did with the exponentials, where if my bases were the same, then I just set the exponents equal to each other. Now, if you have log base b, whatever it is, that's the same on both sides of your equation, then you can set what you're taking the log of equal to each other. Okay? So, set your arguments equal to each other, solve for the variables, simplify, check for extraneous solutions. Okay? Here you go. Here's your first one. Let me see my example. Log, common log, of 4x minus 7 equals common log of x plus 5.
Wait, so what's the difference between what we just did and
So what I was giving you, those last 3 examples were exponentials. You didn't see the word log. You were converting it to a log,
okay.
right? And then what we did at the end of class yesterday, those were both exponentials. On both sides, I mean. Ayla.
Factor?
Eventually. Not right now.
Okay.
So do you see that we have log base 10 or common log on both sides? So just set 4x minus 7 equal to x plus 5. You can solve that, right?
Yeah.
Get your x's on one side and everything else on the other. Mm-hmm.
Can you come? My computer is like, my iPad is like, I cannot write any of these notes down. Like, I don't know what to. And I went down to fix it, and she like, it was fixed down there, and then I came back here and it's still not working. Like, I can't write anything down. It's
Do you know how to print? Like, do you want to go print them and take them on paper, or do you just want to take them on a loose leaf for right now?
I was thinking about I like can't write on my iPad.
Okay, why don't I give you a piece of loose leaf, and you can at least like work through the problems
Okay.
and either add them to your notes or I can send you the notes later. But I do think it's good to like work through them. You know what I mean? Yeah. At least just write them down and work through it. You can add them where you need to later.
Okay, thank you.
Okay, did you get 4?
Yeah.
Okay, so let's just make sure that when we plug it back in, that we're okay with that. So the common log of 4 times 4 minus 7 equals the common log of 4 plus 5. So what is this? 4 times 4 is 16. 16 minus 7 is 9. 4 plus 5 is 9. So what we get is the common log of 9 is equal to the common log of 9. Is that going to get us the same thing? Yeah. So you're good. This is your answer.
Would we have to show our check work, or could we
Um,
calculate it?
Well, I would maybe just don't forget to do it.
Right.
I'm okay if you do it in your calculator, but if you don't say that there's an extraneous solution and it is, then I have to take off, right? Do you have a question, Luna?
Okay, so the only answer is 4.
So the only answer is 4, yeah.
Oh, so the base thing happened, like,
They have to end up, yeah. I mean, if you were to put log of 9 in your calculator, you would get the same thing on both sides of your equation.
okay.
Yeah, good job. Okay, here you go. The natural log of 7x plus 4 equals the natural log of 2x, minus 11. Taking the natural log of these expressions on both sides, that's the same. So just set what you're taking the natural log of equal to each other. Can you solve that? Yeah? Okay, let's see what happens.
No solution.
Why?
Because you're doing it.
Okay, so let's make sure, not just because I'm getting a negative, let's make sure that when I plug it back in, it does give me a negative. So if you do the natural log of 7 times negative 3 plus 4, and then the natural log of 2 times negative 3 minus 11, so that's negative 21 plus 7, which is negative 17. Negative 6 minus 11 is also negative 17.
Yeah, I'm getting nominal for that.
Okay, so then there's no solution. Now, you may, listen to what I'm saying, you may plug a negative in and get a positive number that you're taking the natural log of, which is why I wouldn't just assume always no solution. Are you with me? Okay, so this is an extraneous solution. My something is on something today. Goodness gracious. So I want you to write that this is or I want you to cross that out, and I want you to write no solution.
So they can't be negative.
What can't be negative?
Negative 17 has to be positive.
Right. It is most likely going to be no solution when you plug it in if you're taking the log or the natural log of a negative number.
Okay.
But just make sure you check it in your calculator Because Luna, what I was saying is you may plug -3 back in and it may give you the log of a positive number,
Okay.
right? So there would be a solution. That would be your answer.
But if the ending number is negative, it's like.
Yeah, when you plug it in. What's the other one? Log base 9 of 2x squared equals log base 9 of -4x plus 16. We got log base 9s on both sides, right?
That was a no.
Hi.
Good morning. Oh. Okay, why is this one different than the last two? Thank you. Because it's a quadratic. So we're probably maybe going to want to end up factoring right now. Or do something before I start factoring. Simplify it how?
Divide everything by 2.
Yeah, but can I do something before I do that? Yes, that is 2.
Can I move the x over?
Yeah. Set it equal to 0. So you're going to add the 4x and you're going to subtract the 16, but there's no like terms on that side. And now I want to look for a greatest common factor. I'm glad that's where our heads were at. Hang on, I got to come up here. I've been writing really big. So what multiplies to get you -8 but adds to get you a +2?
+4, -2.
So x plus 4, x minus 2 equals 0. You're solving. So take x plus 4 equals 0 and x minus 2 equals 0. I got 2 answers, which means we have to check both answers.
Are there some cases where one may be wrong?
Or both may be wrong, or both may be true. So here was my warning to you. Plug it back into the original.
With the log?
Yeah. So what do I get? -4 squared is a +16 times 2 is 32. That's when I plug -4 in. So what is that? 16 plus 16, I also get 32. That worked. Do you remember me warning you about the last one? Just because you get a negative number doesn't mean it's always going to be no solution, right? Because I plugged it back in and I got a positive number. Okay, now I'll plug in the other one. Man, I'm really running out of room. Write smaller. Zoom in.
Yeah, that one was too.
Okay.
So then could we just say those are the answers? Or
Both of them are the
could
answers.
we
You're
just,
right.
highlight like x equals -4 and x equals 2?
Mm-hmm. So did you get log base 9 of 8 and then -8 plus 16?
I've been just putting them in my calculator.
Okay.
But I got 0.946.
Okay. All right. So they both work, yes.
Actually, getting -40.
Which part? The first one where you're plugging in -4? Or where you're plugging in 2?
Like, parentheses 2 negative.
Oh my god. Okay, here, just type in 2 and then negative 4 squared.
Okay.
Yeah. Because there are extra parentheses there because of the logs, but you're just evaluating what's in those outside parentheses. Yeah. Yeah. Okay. Now, it's not always that easy because you may have a log only on one side. So we're going to do basically similar but the opposite of what we did when there was exponentials on one side. Here you go. I know, it's a lot.
The test, there's gonna be one problem.
Yeah, so steps to solving logarithmic equations when there's one log. Isolate it, convert it to an exponential, and then solve. I'm going to ask for the exact answer here, okay? And you need to check for extraneous solutions. So here's an example. We'll walk through the steps. Okay, here it is. Log base 4 of 5x minus 1 plus 1 equals 4. So my first step in that box said isolate the log. That means you're getting this whole thing by itself. From the word log to the closing parentheses. So what was your first move? Subtract 1. Now it's equal to 3. Is the log by itself now? Yes. So step 2 was convert the equation to an exponential form. So now you can do the loop-de thing if it helps you.
I thought it was already.
This is in a log form, and you need to convert it to an exponential. You were doing the opposite of it when we started today. So if you do that, here's what it looks like. 4 to the third equals 5x minus 1. Can you evaluate 4 to the third? There's erasers right there if you need it. Do it in your calculator. What's 4 to the third? Okay, 64 equals 5x minus 1. Can you solve that? Yeah? Add 1. You're solving for x.
So x equals 13.
Sure. Let's just check to make sure it's correct, though. Plug it in the what I gave you.
So you're taking the log and then you're putting that into a
Exponential. Yes. Yes.
and before we were taking the exponential form and putting it into a log.
Which is why I had to teach you how to rewrite them as one versus the other in section 4. I got it. Are you with me?
Yeah.
It works.
It works.
It equals 3, right?
What equals 3?
When I plug 13 in with the original, wait,
So log base 4.
is this what?
Oh, so you're just plugging it into what I boxed in.
Yeah,
But then 3 plus 1 equals 4, right?
okay.
Yeah. So Lena, hang on one sec. I'll show you.
Yeah, I forgot the plus 4.
Yeah. Plus 1 equals 4. So Luna plugged this in her calculator and said, I got 3. So 3 plus 1 equals 4. Yeah? Good job. No, that's okay.
I always forget the plus 6.
Okay. What's my next one? Okay, I'll skip one. How about this?
Can we do this one by ourselves?
Sure. I got negative 2/3. Whoops. But when I plugged it back in, I got log base 10 of 10 is 1. 10 to the first is 10.
So we always set it equal to 0. Oh, never mind, that was for the.
Yeah, because we were factoring, and these end up giving you just linear equations.
Okay, cool.
Oopsies, I forgot the 1/2.
Should you check it every time?
When it says check for extraneous solutions, I would.
Yeah.
Because there's a chance that one of them or both of them or whatever may not work.
So the log in this one is only log to the third and then 3x, correct?
So this is what you're trying to get by itself
So would I
before you convert it.
multiply
Mm,
divide?
so this 4
Uh-huh.
is just like added on there.
So could I subtract?
I would subtract, but don't forget to keep that negative. And don't just automatically assume no solution, because at this point, you want to get rid of the negative 1/2.
Right.
So you can multiply by 2 on both sides or divide by a negative 1/2. And then you notice that it changes it back to a positive 4.
Right.
Now make it an exponential. One is 3 to the 4th. 81. So 4 minus 1/2 times the log base 3 of 3 times 27 equals 2. That's a lot. If you evaluate this log, like if you put this part only in your calculator, what is log base 3 of 81? Log base 3.
Why did you go from 2 to -2?
I don't know. What was I supposed to have? -2? Sorry.
Oh,
I just missed it. I just missed the negative. Wait, is it a -2? Hold on. No, I was looking at this one. Ugh, the original. I'm plugging it back into the original, so it shouldn't be there. I don't know why. I'm sorry. There should not be a negative there.
Log 3, you need 4.
Okay. So if we have 4 minus 1/2 of 4 equals 2. 1/2 of 4 is 2. So 4 minus 2 equals 2. There you go.
I kind of like these. These are kind of like.
They're very intimidating. But once you do like 1 or 2 moves, then like you're usually pretty good, Luna.
Are we just gonna like tell, or are you gonna put on the test like solve single log or solve
No, it'll just say solve.
log with both sides?
Yeah, so it'll just say solve. So you kind of need to know like how do I do what? So think about that on your homework when you're doing it, because they are all mixed together. Okay? And tomorrow I can kind of distinguish when we go over homework questions. Okay?
They're like all the same though. Like I
Yeah.
and
When there's one of something, you have to isolate it. When there's two of something, like whether there was two exponentials, you had to get a common base, or if there was two logs, then you really just set it equal to each other. Are you with
they
me?
all look different. It's just
They do.
what to use. The only one
It
that
is.
distinguishes the logs on both sides is log and log.
Do we have to show where we're plugging it in? Like, should we write that all out?
No, I said you're allowed to use your calculator. Just be sure don't skip it.
Okay, 1 minute left.
I know. So can I just let you know that the answer to this one is going to be this. E squared over 7. Do you see? Because there's a natural log, that's the base. So just be careful that you might get something like that as an answer. That is the exact answer that I'm talking about.
Like, don't think it's wrong.
Yes, yes.
Thank you.
Okay.
Thank you.
Do you need me to send them to you,
Like, I
Sydney?
I took pictures in my paper, and then towards the end, the class it started working, and then started. I'm just gonna go get it fixed. I don't know.
Okay, but do you need me to send them?
I think I
Send.
got it all.
Okay, all right.
Do you have it on video?
I should.